Welcome to the SEI podcast series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense and operated by Carnegie Mellon University. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts. My name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I'm pleased to introduce you to Dr. Neil Ernst, a fellow researcher who works in the SEI's Architectural Practices Initiative. Neil has been a guest on our show before when he talked about a recent field study that he conducted on technical debt. In today's podcast, we'd like to talk about his recent research into quality attribute refinement and allocation. Before we begin, let me tell you a little bit about Neil. Here at the SEI, he researches the intersection of requirements engineering, quality attributes, and agile and iterative development. This includes developing new theoretical frameworks, conducting empirical studies, and communicating results to the wider community. Prior to joining the SEI, Neil was a research and teaching fellow at the University of British Columbia in Vancouver. He earned his doctoral degree in software engineering from the University of Toronto. Welcome, Neil.
Thank you.
So I do research in iterative development, agile methods. You're doing research in this area, and out in the community, we talk about the quality attributes of software. Actually, the community mostly talks about the ilities. The SEI, we've given it the name of the quality attributes. But for those of our audience who are not familiar with that term, tell us a little bit about quality attributes. Why do they matter? And how do they interact with software architecture, which is Architecture Practices Initiative, right?
Right. So these are also called non-functional requirements.
That's another term, yeah.
Might be the more common one, I'm not sure. So the way we see it is these are sort of qualifications on the system's functionality. So if the system has to have some kind of login function, then the quality attributes specify things like, how fast that should react and, how.
So often quality attributes add constraints
to
the system. You can't just do anything. You have to do it within this performance constraint, the security constraint, this usability constraint. These are all things that would be quality attributes.
Right. Yeah, I guess so. You said constraints. I think constraints, the way that, we use it is more like the design decisions that you have no choice in the matter, right? So language is Java, you don't have any, there's no decision to be made there. Whereas I think the interesting thing about the quality attributes is, well, for one, I think they tend to be receive less attention than some of the functional aspects. So management is more interested in does it do X and Y, whereas from an architecture perspective, the quality attributes tend to be the ones that have the sort of widest impact on the architectural decisions you make. So for example, I think you can probably choose a number of frameworks to implement a login screen. But if you are concerned about performance, then maybe that narrows down the decisions that you can make about which one you're going to use.
It reduces the trade space.
Right, exactly. And I think the other aspect there is, and I think this tends to sort of be forgotten, is you can't just say I want performance or I want security. These are really trade-offs that you have to make, and I think being a good architect is about understanding which of these trade-offs you are making and which ones you should be making.
So, and some of these trade-offs are actually antithetical attributes. So the classic one is security and usability.
Right.
Exactly. When I have to do a 14-character password with all these sort of attributes, it's not as easy for me to remember as a user as something that could just be alphanumerics.
Right.
And so somebody's got to make that trade-off between which of those is more important in terms of how I architect it and also how I implement.
Right.
So.
Although I was using a new bank site yesterday, and they had a 6 to 8 character restriction, and it could only be alphanumeric, and I thought, obviously in the field, I thought, this is not a good idea. This is going to get hacked easily.
They've really downplayed the security aspect and maybe not hit the right balance.
Yeah, right, exactly.
Yeah.
So I think from an architecture perspective, it's really about, and this is sort of the SEI's architecture approach would be to start with understanding what business goals the system has, and surprisingly often that isn't very well understood. and from there trying to understand what the important quality attributes are for the system.
So let's take this into the iterative development arena, because
Sure.
you recently co-authored a technical report that examines the use of these attributes in iterative software development.
Right.
And what, from that study, what is the current state of the practice? What are the challenges to using these quality attributes in iterative software development?
Yeah, so I think the challenge with quality attributes is that they tend to sort of cross-cut a number of different functional domains. So you might be familiar with like Conway's law, which says like the structure of the organization will be replicated in the architecture of the system.
Right.
So you end up with a database back end and some kind of middleware and then some kind of UI, and those are assigned to 3 different groups.
Right.
So if you have a concern about performance, for example, who's responsible for that? And then the other saying is if everyone's responsible, then no one's responsible.
That's right.
Right. So you end up with performance gets sort of relegated to let's fix that at a later point, and that's really the wrong time to be thinking about that, because this is a decision that will have impact on how you're going to actually architect things.
So in your report, you talk about some methods for refining quality attributes and for talking about them. So what do you mean by refining? Because that's a term that we don't always hear in relationship to quality attributes.
Right.
What does that entail? And then talk about some of the methods.
So maybe I'll just step back briefly to say that the way that we think about quality attributes, for example, if we're doing architecture analysis, is as sort of these 7-part scenarios. And the scenario is like a use case or whatever, a way of sort of testing the design of your system. And we say it's 7 parts because it has different aspects to each scenario. And I think the 3 ones that are important for this study were the stimulus, so where what's instantiating this or causing this to happen, the context, so in what environment is this sort of normal operations, or is this some kind of firefighting environment that you have, like not literally firefighting, but something's gone wrong.
Or degraded operations.
Right, degraded operations, better term, thank you. And then finally, what's the response measure? So we're pretty keen on having some kind of numerical or quantifiable measure of, yes, this scenario has been satisfied. And I guess here I could ask you, these scenarios to me have always sounded a lot like what you see in behavior-driven development approaches or acceptance testing.
Right,
so
acceptance test-driven development.
Right, in the sense that if I am going to accept this system, or if I'm going to say the architecture is sufficient, it has to be able to deliver performance under a second or something like this.
And what I see in iterative development is incorporation of these kinds of quality attributes into the definition of done. So in iterative development and Agile in particular, you'll have acceptance criteria for functionality, but a lot of times the acceptance criteria doesn't really deal with the non-functional requirements of the quality attributes. And the way that we recommend people get at that is that the definition of done includes all those things that you want everything to meet. So if you've got a performance issue or security, whatever, you want to figure out what that is. And then of course you've got to figure out how to test for it, how to verify it, all those things, but you don't allow it to slip under the radar. You make sure that it's explicit. And that's one of the things that we're finding is useful, but it's, and we're also finding one of the interesting things is the non-functional requirements has been picked up by a couple of the sort of scaled Agile framework developers, but the quality attributes, I get a lot of deer in the headlights. It's an SEI-centric kind of term, but in practice, I don't care what term you use as long as you're paying attention to it. So
absolutely.
So the refinement aspect of quality attributes is you're using the scenarios to figure out how to tweak those quality attributes so that they meet some new stimulus, so that they are able to create some new response that may not have been part of the scenario before. Is that a general approach?
So I think going back to what you were just saying, it should be made explicit. But now the question is, if you're doing iterative development, well, when do I do this? Like if I have a security response measure that says no one should be able to break in. Well, do I do it in this sprint or the next one?
Right.
And of course, these iterations vary widely in length and size. They're not
we
all,
found that too.
Right. So part of the technical report and the blog post looked at different ways that people refine or slice user stories in practice. So, for example, there's a number of writers out there on blogs and in the community that talk about, and this is a common problem in functional and non-functional or quality attribute stories, is how do I take this big thing that I was given and turn it into the appropriate chunks.
Alistair Coburn talks about lamination.
Right.
What's the next smallest increment of value I can deliver and sort of layer on top, and he thinks about it as a laminating process.
Right.
That's been a useful metaphor.
Okay.
But it's still hard. Lamination is not an easy thing to be doing. If I can just cut one panel through, right? I think that's easier.
Yeah, so part of what we did is just survey the different approaches that people had for doing slicing in functional areas. So the common one that people tend to do, and I think it's part of this Conway's Law idea, is sort of this horizontal slicing. So horizontal, if you think of like a layer diagram, you slice based on, let's do the database part in this sprint, and let's do the middle. I mean, I'm simplifying obviously, but so that horizontal slicing people have sort of now realized is a very bad idea.
Yeah,
right?
It's not recommended by most of the agile thought leaders.
Right, because you end up with these weird silos, and now you're like, well, how do I get this layer to talk to that layer? That wasn't part of any of the slices. And then the other, maybe more preferable way to do this is the vertical slicing, where you say, well, let's just start with a very simple use case, log in, get the data from the database or whatever. It's not very fancy. You don't have any of the UI Chrome on there, but it's walked end to end, so okay, this is all working together.
Right.
And Alistair Coburn, you mentioned him, has this other, I think it was his idea of a walking skeleton. So you end up with very simple thing, and that you then flesh out later and add the other elements that you're interested in.
And we find the walking skeleton idea is important because if I don't, and that relates to architecture as well, that's really an architectural construct. If I haven't gotten some good ideas about how the architecture could work, then I'm going to be making decisions locally that may make me not able to walk anymore, to continue that metaphor. So there's a lot of architectural implications for that.
Yeah, so that refinement is essentially some kind of decomposition, slicing of the bigger quality attribute requirement into the smaller pieces that will be iteration size and length.
And we're seeing that in the DoD environments that are trying to adopt agile methods. The security one is the one. There are organization, back to Conway's, there are organizational constructs that are responsible for certifying a system for operation in its setting, intended setting, and there's tons of security requirements that go along with that. And in a traditional development, those don't get tested and really dealt with until the end.
Right.
And with iteration, how do I slice that security requirement into something that is either useful to implement, or hopefully not just useful to implement, but also useful to verify at that point? And when can I say I'm done touching that? Because I can't verify it till I'm done touching it. And there's a lot of implications to that refinement aspect. In that arena, it's maybe more obvious than some of the others.
Yeah, I mean, I think one of the dangers of this horizontal slicing approach is that if you say performance is important, and I know these three groups aren't going to cover it, let's assign it to some kind of architecture group. But now you get this separate problem of, well, no one respects the architecture group because they're not writing code and they're up in the, they're astronauts, to use Joel Spolsky's phrase. So I think that can be done in such a way that doesn't have to happen, but it's a bit of a risk. Yeah, right.
It's harder because you're, as you say, there's not as much, it's not a team that's looking across the layer, or that's looking around the layers. They're looking just across their own layer.
Right.
And that creates a different kind of teaming environment.
Right.
So this allocation to iterations, have you found any patterns that seem to be more promising than others? I mean, we talked about the vertical versus the horizontal, but are there any other aspects of refining into iterative elements that you would recommend to current developers, students, et cetera?
So I think in the study, so I think the quality attribute scenario is essentially this vertical slice, essentially. And now the question is, how big a slice of this cake, if you will, are we going to take? It should be, big enough to finish, or small enough to finish in one iteration, so we can say, hey, we finished this. So we went out and talked to 3 different organizations that were dealing with these problems, and they had their existing practices. They were doing iterative development of one kind or another, and we wanted to know, well, how do you handle things like performance requirements? And this one example was a financial services company, so performance is very important to get the orders back and forth. And what they do is what I think it's Martin Fowler talks about this as threshold testing or something similar.
Okay.
The link's on the blog post. And the idea there is that you do this thing called ratcheting. So instead of starting with the absolute essential requirement that the system has to meet when it's delivered to the customer, whoever, for example, it has to be the order has to be processed in under half a second.
Sure.
You can ratchet to that level by the response measure in this case, by starting off with something simpler, like let's get this done in 10 seconds, or maybe even the simplest thing is just let's get this done. And then as we go, each iteration we ratchet or tighten the performance threshold until we're at the half a second.
Yeah. And this is the sort of truest form of iteration, where we intentionally know we're not delivering the requirement in iteration 1.
Right.
We are going to incrementally iterate to get up to the point of performance or whatever that we need.
Right.
And we're finding that that's one of the things that's a difficult shift for organizations moving from traditional to iterative, is they don't think about the fact that they actually can address this again in another iteration if they're mindful about how they design it. I mean, that's the key to ratcheting or any of these strategies is I know I'm coming back to it, so I design it in such a way that that's feasible. And so loosely coupled, all those other kinds of things we talk about are important if you're going to use that strategy.
Absolutely. And I think that the danger from an architecture point of view is if you set the initial measure or ratchet too high, you may end up choosing an architectural approach that precludes you from getting to the ultimate
goal.
Right?
Local optimization.
Right.
Yeah,
right. Exactly.
yeah.
And I think the key here is to understand the sort of response curve. So if you said in the performance case it has to be half a second, and you start at 10 seconds, well, the assumption there is that it is indeed possible to get this with this architecture from 10 to 0.5. But that's not always the case, right? It's not necessarily linear. In fact, it's almost certainly not linear in the case of performance. At some point, you'll run into an obstacle that prevents you from getting to the desired criterion. So that's ratcheting on the sort of response measure. The other things that we found these organizations doing was ratcheting on the stimulus. So for example, you can assume if someone's sending an order in through your online system, that the stimulus might be when the user clicks the button, and that's the sort of end goal. But if you wanted to make it simpler for the first few iterations, you can say, well, I don't know how the UI is going to process that, but let's assume that we've got this request at the middleware layer, and then go from there.
Right.
And then, so the ratchet
expand.
then is, let's expand it out. And the other one would be, back to the quality attribute scenario, is the context. So if the context is normal operations, maybe everything works fine. And now we can ratchet it to reduced operating capability, or servers gone down, or whatever, and handle that scenario somehow.
Or increase volume and things like that.
Right, exactly.
Cool.
So that's a way of, and this is how these companies were doing it, sort of assigning these things to different chunks of their
What's very promising to me is that they or you could actually associate what they're doing to these different aspects of the scenarios, which really kind of validates the utility of the scenarios for expressing these kinds of attributes and helping people to understand that there's choices to be made all along that curve.
But I would say that your point about, I guess, trust, which is a big part of Agile, is key. So these are organizations that were sort of self-contained, right? Their customer was essentially themselves. So you could sort of trust that you were going to get the job done. It wasn't like you were asking a contractor to do it and you weren't really sure if they were going to deliver for you. And one of the keys there, I think, is knowing, like I was mentioning about the response curve, knowing exactly what that looks like. So you might have to have some other group go off and prototype or do a spike or something to say, oh yeah, this is possible.
Do the research needed, yeah.
Right.
Yeah.
But if you don't have that level of trust, then it's going to be difficult to say, okay, it's not what I wanted right now, but I know that you'll get there at some point.
Yeah. And trust happens over time. It's not something that builds right away. And we have a whole bunch of things about that.
Right.
So the takeaways I've got from this are that non-functional requirements, quality attributes, they have architectural implications in iterative development, but they also have implications to the iteration itself. And looking at strategies for refining how we see those quality attributes evolving is one of the strategies that we actually have an opportunity to take advantage of in Agile, which we don't have as much opportunity in other methods. So that's the takeaway for me. And then the other takeaway is that you've got to be mindful about doing that. You can't just assume that that's going to happen, that's really got to be something that you think about as you're putting your development strategy together, possibly your organizational strategy, going back to Conway's Law. Any other takeaways that people should think about when they're thinking about this work?
I think, back to that, sort of when do you do this, how do you do this? I think, again, the open question is, how exactly, if you're in a large organization, how do you structure your sprint cycles, when you do planning and so on? So I know there's approaches like the Scaled Agile framework that have an explicit architecture runway where someone should be, or some team should be thinking about these issues. And like you were saying earlier, I think it's really key to make these things explicit. So whether it's an acceptance criterion on an individual story, or it's a specific story in itself,
or it's a definition of done for the release.
Right. Yeah. There's you have to have some way of understanding when and how and who is going to be responsible for that.
Good. So what comes next for quality attribute refinement? Where are you going from here?
Well, I think what we're currently working on, focusing on, is technical debt, and I think a big part of this type of refinement is a source of technical debt if done poorly.
Okay.
So we're exploring that in the context of technical debt management, and again, I think the theme behind all of this is this idea of making things visible. So whether it's when you took on this decision or what iteration it's supposed to be done in, it has to be visible, if only for your own sanity, so you know why you did something, if not for the next team that's going to
for the sustainers of your system.
Right, exactly.
Download. Yeah, that's important.
Right.
Well, I want to thank you very much for joining us today.
You're welcome.
I love talking about this stuff. Well, actually, EPEC knows I love talking about this stuff. You're just learning how much I love it. But we do want to look forward to talking to you again as this research progresses and your technical debt research progresses. For viewers that want to look at the technical report that Neil has authored on this topic, please visit resources.sei.cmu.edu. Click on the Browse by Author box and find Neil's name. Ernst is how the last name is spelled. And we will also include links to these resources in our transcript. This podcast is available at the SEI website at sei.cmu.edu/podcast and on Carnegie Mellon University's iTunes U site. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thanks for listening. Thanks for watching.